This is video 932, and the goal of this video is to be able to graph translated parabolas written in standard form. So, of course, like you did in class with your assignment 9.3a, you have to first put things in standard form. But we're going to take a look at some rules that are already put in standard form and talk about graphing them. So we have the graph, the equation x minus 3 squared equals 8y plus 1. So first of all, I'm going to rewrite one more time and think of this as 4 times 2 times y plus 1. Because that allows me to see my p-value is 2. And I can also see my vertex is 3, negative 1. Because of the h and k values. So when I start my sketch, I'm going to start over at 3, down at negative 1, and that's where my vertex is. Now the question with the p-value is, am I going to go left or right or up or down? So we take a look back at the rule in standard form, and we see that the x is squared. And so this is going to be a vertical parabola that will either go up and down, or that will go up, or that will go down. In this case, it will go up because the p-value is positive. So that means my focus is going to be, I'm going to add p and go up to my focus up here. And my focus will be at 3, 1. My directrix will go down 2 and be down at negative 3. And that's where my directrix will be. And the equation for the directrix is a y equals negative 3. And so the last thing that I'm going to do is, in order to finish the graph, I need to find the latus rectum, because that's going to help me describe 2 more points to draw the curve, because right now all I have is this one point, the vertex. So the latus rectum is always the absolute value of 4p, that's how long it is. So in our case, the absolute value of 8, because 4p was 8, so we can see in both of the equations. So 8 is the length of the latus rectum, and so remember that means from the focus we go 8 all together, so we're going to go 4 to both directions, and that's how we'll find our points. So we'll go 4 to the right and we'll go 4 to the left. So these 2 points will be at, let's see, 7, 1, and at negative 1, 1. That's my 2 points that I can graph in order to see my sketch. So my parabola will go through those 2 points as well as the vertex. So it's a pretty wide parabola. Add some arrows and you're good to go. So that's probably the most interesting part of this whole process, is finding this distance here. And altogether it's 8 but 4 in both directions from the focus to find those key points that you need to graph the U-shaped parabola. So that's it. That's how we graph the parabola and find those key values. Let's see, we found the vertex. We found the focus. The focus, remember, was at 3, 1. And we found the directrix of the parabola. So let's take a look at another example where it's the opposite, where we're given the equation and we're asked to find the rule. So let's start off with figuring out what kind of rule it is. Is it a y minus k squared type of rule? Or is it the other way around, where it's x minus h squared with the y minus k on the other side? So we take a look at the direction of the graph and we see that it is directed to the left. And so the graphs that are directed left and right are the ones where y is squared. And that's just something you're going to have to memorize. So we're going to use the top equation and ignore the bottom. The second thing we notice is that the graph goes to the left. So it's going into the negative direction. And that tells me key information about my p-value. So that means my p is going to be negative. Okay, that's for sure going to be negative. Another reason we can see that is if we walk from the vertex to the focus, we see that we go backwards 3. So that's another way we can see our p is negative. So far I know it's 4 times negative 3, x minus, so I need the h, And the vertex, maybe you can't read that, it's a little hard to see, is 2, -1. That's what this little bubble says here. So my vertex is 2, -1, so it's going to be x minus 2, and it's going to be y plus 1 squared. And then you have your rule, and you're done. A couple of things you can do to check your rule are things like plugging in points. This point right here is -1, 5. If I want to see if my rule is right, just the old-fashioned way of plugging in -1 and 5. So I plug in 5 for y, and I plug in -1 for x. And I would see if I actually get equal statements. So on the left, I'm going to get 36 because 6 squared. On the right, I'm going to get 4 times -3 is -12 times, oops, and I did write something wrong. It should be -1 minus 2. Sorry, I dropped that down wrong. So now it looks like I will have -3 on the inside. And so when I multiply that, I do in fact get 36. So I checked with a random point I hadn't used yet, and it worked. So odds are my rule is right. If I wanted to be super sure, I could plug in other points. I could plug in the vertex. I could plug in the other point at the end of the lattice rectum. Now this rule that we wrote, one quick thing we could do to make it just written a little bit nicer is to simply rewrite it as y plus 1 squared equals -12, x minus 2. It's typically how it will be written just because it's simpler, it's less numbers, less stuff going on, and we can always factor out the 4 when we want to. So your job for the checkpoints is to kind of repeat this process with 2 different types of problems. So question 1, find the vertex, axis, focus, and directrix of the parabola by completing the square on the equation and graphing. So find those key pieces of information, but make sure you graph it as well so we can check your work. Because you may be able to find that information, but maybe the graphing is the hard part. The next question is to write the rule. And I'll add some numbers to this if it helps you. First of all, this is the focus point right here. This little asterisk is at -2, 2. A couple of other key points, the vertex. This is -2, and it hits the x-axis. And that, honestly, should be all that you need. There, you don't need the lattice rectum in order to write the rule. So see if you can write the rule there. And check, you could check by looking for what you think the lattice rectum should be. Remember, it would go straight through this. And seeing if those points actually are on the graph. So you can probably figure out what those points are. But bring your questions into class, do your best, make sure you fill out that Google form, and we'll get some help on this the next day.